So this is a retro for the task that I didn't solve like a couple hours ago. Um, After like checking, there are I I basically decided to solve it with a hash set approach, and submitted it, and it was working, but the tree was not working there. So let me just program the solution and discuss the trade-offs, etc., etc. And also I'll try to kind of do that from scratch. Not from scratch. From scratch, yeah. So from the reading problem description and then programming that and then testing it and then maybe checking for improvements. So this is this problem, length of longest valid substring. We have a like blacklist forbidden strings, and we have a big word, and that's forbidden strings there. It's an array. It has like maximum 10 lengths, and for length of that array, number of forbidden words, like blocked words, is like 10 to the power of 5, and the word length where we gonna try to find the consecutive sequence of letters, and that sequence should not contain the blocked words, and we should return the maximum length of this consecutive sequence of characters. So let me copy this one. I'll copy this one and I'll try to explain my approach, how I see that right now. So we have like this sequence, we have a couple of forbidden words, and the output should be 4. Okay, so the output should be equal to 4. So we have this word. Then number one step, I'm gonna add those forbidden words to the hash set. So I add and then I add hash set, add CB. And then what I'll do, I'll have this approach, 2-pointer approach, and I'll have like right and left pointer, let's say left and then right pointer, and every time I'm gonna move right pointer and check if the word starting from the right, and then I'll check word length 1, I'll check word length 2, and I'll check word length 3 and up to 10. And if it is not forbidden, I'll do the if none of it is forbidden, I'll do the update the max output. But if some of them are forbidden, I'll need to move the left pointer to the right. So let's assume I have, let's say, so I need to check like maximum 10 characters in order to figure out, okay, this like new sequence that ends at R, is it like a valid one or not? If it has like some part of it, it has like the suffix of it has a forbidden word, it means that this sequence is forbidden, and because it has a forbidden word, and I should move a left pointer so that So that left pointer should be pointing to the next, to the one word that's like +1 to the left of the smallest forbidden word. So that's the idea. So the idea is that I need to, on every iteration, I need to figure out if, let's say on the first iteration, I have possible windows for the possible windows, this one, and then for the second iteration, I have possible windows, this one, and then for the third iteration, I have possible windows, this one, and let's say we have let's say we have C, B, A, and then BC, and we have 0, 1, 2, 3, 4, 5, 6, 7 indexes, and let's say I want to know what the length of the sequence, of the maximum sequence that ends at, let's say, at 3, and that doesn't have forbidden words. So I'll start with basically I need to start with like minimum length, but I'll start with like length 1, and I'll try to do substring and check if this word of length 1 has is included in the hash set of blocked words. If no, I try to do this length. If no, I try to do this length, and so on and so forth, until I either reach the maximum of the window, is equal 10, because maximum length is gonna be 10, or I will, if I reach the maximum 10 and I didn't find the blocked words in the end, so I need just record what the maximum sequence that adds, maximum sequence length that adds at A. If at any point let's say we have this one window has is included in the block list, it means that if we go from less size to more size, it means that the previous one was not in the block list, and it means that I need to move the left pointer here, and then I'll need to update the current maximum sequence that doesn't include the forbidden word, and that ends at A, at 3. So let's go one by one. I'll explain that in details. So initially we have right pointer equals, let's say left pointer equals 0, right pointer equals 0, and we need right now check whether this kind of windows that included in this sequence, whether it's included, whether blocked words are included there. So I'll start with the C. So I'll have the substring C, and then I check if it's included in the hash set. It's not included in the hash set. It means that I need to move the right pointer. So I have left equals 0, right equals 1, and now and the max here also max length that ends at 0 gonna be final right minus left plus 1. So the len here gonna be 0 minus 0 plus 1 gonna be 1. So here when we have CB, so any subsequence that add B at the first index, so I first check the len equal 1. So just B. Is it included in the hash set? No. So next one, I check lang equal 2. Is it included in the hash set? Yes. CB is actually including hash set, it's blocked word. It means that we need to roll back. We need to move left pointer to the one to the previous to the right minus previous len of the values of sequence. So left pointer becomes 1. So we subtract r from 1. We subtract length. So it was 1 plus 1. So it's gonna be left gonna change to 0 to 1, and then len in this case gonna be 1 minus 1 plus 1 gonna be 1. So I move the right pointer, right equals 2, left equals 1, and I need to check again, are there any words that ends at a, are they in the hash set? So I check if a in the hash set, no, I update the line, and then become 1. Or like we just increase r. Oh no, I decrease L. So I do the, and I should not pass the L. So I should go, let's say we have L equals 1 and R equals 2 here. So I try to check this window. I try to check this window, and then I check this window. If I start checking like that window, it will basically will start including the not allowed word, blocked word, and that will break everything. So L from 1 to 2, and then we need to check if A is in sequence now, if AB is in, if BA is in sequence, of if it's in a block words, no. So it means that len becomes 2 minus 1 plus 1 equals 2, and in this case len equals 2, and then we don't need to move left pointer. So we then do this left equals 1, right equals 3. So we advance R. We again check first this subarray, and then we check this subarray, and then we check this subarray, because it's up to the L, and L equals 1. So we check A, is it included? No. We check AA, is it included? No. We check AAB, is it included? No. So we do the following. We do len, in this case len is equal 3 minus 1 plus 1 equals 3, and then we advance R. So R becomes length, L becomes equal, 1 stays 1, and right becomes 4, and we stay like here. And we do again, we check from the end, we check if A is included in our block list, no. If double A is included there, no. If triple A is included, yes. And it means that left pointer need to travel to the previous position, to the previous valid length. So left needs to go 4 minus 2 plus 1, and it's gonna be 4 will be equals 3, 3, and right equals 4, like this calculation. And then max len will be 2, like len will be 2. So we do the next one A. Here we have right equals 4, left equals 3. So right equals 5 actually, because we advance right every time. And we do that again. We find that the blocked word, we have len equals 2, and then right equals left equals 4. And then we do the B. We advanced right, so R equals 6, left equals 4, and then we check if B is included in the block list? No. If AB is included into block list? No. And if AAB is included in the block list? No. But we reached the left pointer, so we do this len. In this case gonna be 6 minus 4 plus 1 gonna be 3, and we do that for the last one. We advance right pointer. Right becomes 7, left stays 4, and we again check all the subsequences starting from length 1 at A. So A, is it included in the blacklist? No. Is BA included in the blacklist? No. Is ABA is included in the blacklist? No. Is AA AABA is included in the blacklist? No. So we reached the left equals 4, and then len in this case is gonna be 4. So it's gonna be 7 minus 4 plus 1. And then as a final result, we need to check all the len value and the output the maximum one. And this in this case is gonna be 4. And that's basically the output for this problem. So let me start programming this one. Also, while discussing the problem, I figure out that we don't need to actually to check starting from 1. We need just to check from the minimum len for the block word. That will save us some time for calculating all of these things. Okay, so let me start programming that. So we have Leetcode. That's not working. Okay, maybe interview Leetcode. So I'll have this code. Let me remove that one so I won't be looking at that one. And fair game. Oh. So the initial thing that I wanna do is do that import Java util hash set, and then I'll have this hash set string blocked, and then new hash set have string, and then get string. So for int f equals 0, f, let's say for string for b, then in for b, then I need to go int min len equals, say, forbidden length, and then max len equals forbidden get 1. I'll say get 0. Get 0, maybe get first length. And then for every forbidden, I'm gonna add first to the blocked, and like offer, or just add forbidden, and then min len equal mass min len blocked length. Then the same manipulation for the max length. Max len, and then here max. And then next one I'm gonna have integer result equals to 0, or like, yeah, 0, and then we have int left equals 0, int right equals 0, and then for int I equals 0, I less than for r equals 0, I less than word length r plus path, and then what I need to figure out if so for int I equal int len l equals say len equals min len, and then while len less than max less or equal max len plus plus, and then I need to do this string candidate equals word substring they have while and I wanna do that r minus len plus 1 greater or equal l. So we need string candidate equals word substring, and we need right minus len plus 1, and then right plus 1. Here it's just the definition for the left, for the what? For the left bound for the candidate word, we're gonna check in the blocking, in the blocked list, and this one we need to do so like substring accepts like left bound, right bound, left index, right index, but right index should be not inclusive, so it should be plus 1. And then we check if max, if blocked contains candidate, it means that and break. Otherwise I need len plus plus. Then we need left equals r minus len plus usually plus 1, but plus 2 here, because plus 1 is gonna be just the candidate, but we need to move one character further to the right, so it becomes not equal blocked. It becomes not it won't the blocked hash set won't contain that word substring, and then we need to update the length, something like result equals max r result, and then right minus left plus 1, and then we need the return result. So currently I'm thinking about like if it has a blocked, then we need to update left. If it doesn't have update any, it doesn't have anything there. Okay, and we also need to check, okay, if that maxlen, yeah, maxlen, okay. So that's it. Let's quickly do the paper testing. Static void test 1. Then let's do this one. Word. Okay. So we need to get this input. Have string word, and then we have string array forbidden. And then int expected output equals 4, and then we have main solution equals new main, and then I'll do sol longest substring. Here word forbidden. Here it's gonna be the output equals this one, and then boolean passed output expected output, and do this. Okay, so this one is a problem. Let me paper test it. So initially min lang will have equals 2, max len equals 3. And then we do left equals 0, right equals 0, and then we do this this word traversal. So we check here if len, okay, if len is less than max len, and len, if it's less than max len, yes. Yeah, so the min len gonna be equals 2, and then it's less than max len, yes, and then r 0 minus 2 plus 1 gonna be minus 1. Minus 1 is not greater than 0. So we skip it and we update the result. Result equals 0 minus 0 plus 1 can be 1. So we move left pointer stays the same, right pointer we advance it. So you have this word. If you have len equals 2, len less than max len, okay, less or equals, that's true, and then write 1 minus 2 minus 1 plus 1 0 greater than equal, that's true. So the candidate is gonna be r minus, so from 0 to 2, but 2 not including 0 1. So 0 1 gonna be CB, candidate equals CB, and then we check if it included in the blocked list. So we have CB here, so it's included. So what we do in this case, we do L will be equal r minus length plus 2. So r1 minus 2 minus 1, and then plus 2 gonna be just 1. So L gonna be 1, r equal 1. Result will be 1. And then we advance the right pointer. Right pointer points at 2 now. And we do the following. I do the following. Again, I go through the words. I go through the lang, and then lang equal min lang. Yes. 2, and then 2 minus 2 plus 1 gonna be 1, should be greater than equal than 1, that's true. So I do this 1 2 index check if it's included in the blacklist. So it's BA and it's not included in the blacklist, so we do len equal 2 minus 1 plus 1 equals 2, and then result equals 2. So we advanced, next we went to the end, and we go again to the right, we advance right is equals 3, L is equal 1, and then we do the check is max len, so len 2, and then r minus 2 plus 1 gonna be 3 minus 2 1 plus 1 gonna be greater than 1, greater than or equal. So the candidate gonna be r minus len, so 3 minus 2 1 plus 1 2, and then 2, and then okay, from 2 to 3 including, so it's gonna be double A. Yes, C. We check BA, and we also yeah, we check the PA. And then now we try to check AA. And so forth so on. I assume it's working now. Let me check that the Leetcode. Actually, I need to run it. Let's try to run it. First here. 21. Eight. Ten. Six. Okay, so this is array list. So we need to do this equals and then we need to do this and input for I equals 0 and 11 plus and we need to add the input I. Okay, so the test one passed. Try to submit it. So output in this case me debug that one. What if I do start from 1? No, it doesn't make any sense, but yeah, the same one. Okay. Let's copy this and figure out why it's not working. Output expected 4. Okay, cannot see that right now. Let's do the paper testing for this one. So, output expected 4. Let's give it. I'll give it try. Test 2. Let's run the code. Okay, as expected. What I need to do next is the paper tested. Why the output in this case gonna be 5? Clearly Okay, blocked size. Blocked. What does it mean? Forbidden. Length. That was silly mistake. Okay, so this was a hash set solution. Um, let's develop something a little bit better. So as you said, as I said, for this solution, what's the time complexity of this solution? So we need to go window. So we have time complexity. So we have this window. So we go through all forbidden words and we add that to the blocked array. So it's like or for, let's say, f of b, where b is length of forbidden words. And then we need to space. We need of b, again, to save that in a hash set. The second one, we have of v, and on every iteration we go from min len to max len minus min len. If I wanna like upper bound, so it's gonna be the max len is less or equal 10, so like w multiplied by 10, so it's gonna be just of b plus o of 10 multiplied by v. And because we have like here we have substring, we have kind of that situation where we do substring search. What I really want to do, like this substring will always give me like whatever we have, like maximum 10 length copy, so like copy to up to 10 symbols every time on every iteration here, and maximum symbols are gonna be copied like 10, and every time we check the hash set we do this calculation of the hash code for the string. That's gonna be basically the length of the every forbidden word, and yeah, and to calculate, like we added there, and we need to calculate if it contains, we need to calculate the hash code of the candidate, and the candidate length can be maximum 10. So like there is a minor improvement, and that improvement will help a lot if we will have like like length of forbidden words greater than 10. So what I suggest is, instead of having this hash set where we calculate the every time we check the candidate, we need to calculate the candidate hash and compare it with whatever hashes we have in the hash set. What I suggest is to build the tree from the end to the start for the symbols. So we'll have in the forbidden we have AAA and we have CB. So for the A we have like initially we have A, and then we move to the A, and then we move to the A, and that's gonna be like 3. and then this one gonna be end of the word, EOW. And then for the CB, we added to the tree like C, and then we go like next one B, and then we need to add of word. We add the flag and the word flag. So next time when we need to check if the word is actually included into the into this tree, we need to go from the, let's say we have like the word A, B, C, and then C, B, yeah, and we need to check if the suffix of this word is included into the blocked words tree. So I go from okay, so I need to go from the end, like here, like it should be B, and then here it should be C. B, C. So I go from the end, I check the B from the tree, okay. I go B, and I go to the next symbol. I check C. I check. I first go B and check if it's end of word. No. Then I move to the next character. I check C. Can I go to C? Yes. And it means that I need to check just if it's like end of word. So it's end of word. It means that this suffix included in the blocked words list, and I need to basically move the left pointer from here, pointing here. I need to move it to up here to the last successful kind of length of the suffix that is not included in the blacklisted words. So that's it. Let me quickly implement this change. So we'll have a private static class tree node, and then we have public if boolean is end of word equals false, and then I'll have this public tree node subnodes equals new tree node. We have like 26 lowercase letters, English letters that are in our alphabet, and we'll have public tree node. And what we need to do is to have this private function private void add word to tree, then we have tree node root, and then we'll have string word, and then say for int I equals word length -1, I greater than equal 0, I plus plus, and I need to go tree node current equals root, and then I need to go if current word char at I minus a is equal null, then I do this current word sub nodes here, sub nodes equals new tree node, and then I need to equate current. Okay, I need to just return the yeah, so I created it, and then I do this current equals current of this, and in the end I need to set the current if end of word equals true, and then I need to implement another function void check if, and then integer if in is word in blacklist is word suffix, and then we're gonna return -1 if that's false, so the word suffix not in the blacklist, and we'll return lang if false, and we return lang of the last successful, like last not included suffix, not black listed suffix. So, and here we have string word, and then int left, int right, and then we have like tree node root. And then what we do is to go from right to left for int I equals right, and then whatever is less I greater or equal max left, and then right -10 +1, and then I need to do this I minus minus, and then gonna be just length whatever length, and then I need to check so I have the same procedure. Basically we have current equals root, and then I need to go null, then return -1, and then if current is end of word true, then I need to return len -1, and then in the end I need to return -1, return yep. So that's it, and then Then we need to go through the, like, here instead of blocked we'll have tree node blocked equals new tree node, and then we do this one. Then we call the add word to tree, and then we do this. We need forbidden blocked tree, we need this one. We do this add word to the tree, and then we do the len. We do this is then we need word blocked tree, and then if len not equals -1, then l equals right minus len +1. Let's check if it's gonna run. Mm. 28. Char at so r minus len +1. Okay, new. And then also I need to check that here if this less than 0, I need to return -1. Oh wait, just break. What? Mm-hmm. That's quite interesting. Why we have this problem? Yeah, I'll probably stop recording and I'll go plug in my computer and then I'll continue solving this problem.